Okay, so next part, we go on to section 3.2. What are the common types of resistors? So this is what you must learn. This is the learning outcome. Very important. By the end of this short video, you should be able to describe all the different kinds of resistors. Basically, we are looking at two, the carbon resistors and wire wound resistors. Okay, and then depending on what is your application, we have to choose the correct kind of resistors. Okay, so first of all, there are two kinds of resistors, mainly the fixed resistors, where what you see is what you get. You can't change the resistance. Okay, and then there are another kind called variable resistors. So let's take a look at fixed resistors first. So in fixed resistors, you've got two kinds: the carbon film resistors and the wire wound resistors. So there are a couple of different looks to the different resistors. Usually, wire wound resistors, they are for bigger power applications. They are bigger in size. Okay, whereas carbon film resistors, we'll be using a lot of this in our course. They are for smaller power applications and therefore smaller in size. So for carbon resistors, like what I said, we'll be using a lot of this. They show you an internal structure of this. Okay, and for the wire wound resistance, this is what it looks like inside. You can slowly take a read yourself after this video, or you can pause the video and read now. Okay, so what's important is that you know the difference. Okay, so you have to know the difference between carbon resistors and wire wound resistors. So, like I mentioned earlier, carbon resistors, they are smaller in size. They are usually used in low power applications, and for wire wound, for higher power applications. They are very stable for carbon resistors at low temperatures. But in certain environments whereby the temperature heats up very, very high, don't use carbon resistors because they're not very stable at high temperatures. Use wire wound resistors. Low power, high power. And of course, when you talk about what carbon resistors, because, well, the cost of application is low, that's why you get kind of all these lower power application, low temperature stability. But if you want it to withstand greater temperatures, be able to work with high power, is going to cost you. Okay, so you must remember this table over here. So I'm going to write down, remember this table over here. Okay, besides this, you must be able to also remember what some carbon film resistors look like, what some wire wound resistors look like. Okay, and then so we talked about fixed resistors just now. Now we're going to talk about variable resistors. For fixed resistors, what you see is what you get. If I give you a fixed resistor of uh, 1000 ohms, that's it. You can't change it. But for this particular section, when we talk about variable resistors, is going to, the good thing about this is that you can tune it to a particular resistance you want. So you've got your rotary potentiometers, trimmer potentiometers, rheostats. These are what we have in our science labs. Slider potentiometer. So a lot of people get a little bit confused about this word, potentiometer. A potentiometer is something that we can split the potential between 3 points. Okay, so point A, B, C. We can split the potential. If you remember the earlier chapter when I was teaching you about potential, it's how much energy is available at that particular point. So we can actually split the voltages at different points. And if you look here, I've got 1, 2, 3 legs. So typically a trim pot, a short form for trimmer potentiometer, is trim pot. It has 3 legs. Okay, so remember that. So you can talk about this. Excuse me. Just know that variable resistors allow you to change the resistance depending on the situation, depending on your needs. Okay, and so if you look at the rheostat here, it's big. It's literally this big, right? So because of its size, it can handle much higher current, and therefore is also suitable for high power applications. Okay, so I have a certain application. Let's look at review question 3.2. I've got a certain application that requires a resistance carrying current of 3 amperes. Now, 3 amperes is actually a very, very high current. It's very high. Okay, in our course of study, we would typically be only using on an everyday basis maybe zero point 0.5 ampere. So 3 amperes is actually very high. So if you're talking about a higher uh, current which requires working without overheating, then a wire wound resistor is better, because a wire wound resistor is able to hire a higher power application. Okay, carbon resistor, not so. So name the 3 common types of variable resistors. You can come over here, choose any 3. Okay, so you have to remember the names of the variable resistors. Can? Let's go on to section 3.3. How do we determine the value of a resistor? So we've got all these sorts of resistors, variable resistors, we've got fixed resistors. How do we determine the value of them? So for certain resistors which are big, simple, they just print the resistance on the casing itself. So in this case, it's got a 10 ohm printed on it, and therefore it's a 10 ohm resistance. But if you look at small carbon resistors, the type that we deal with in our course, they're very, very small. There's no way they can print out figures on it to tell you the size of the resistors. Therefore, what they do is that they use resistor color banding codes. Okay, so if you look at the resistors, the carbon resistors we have in our lab, they've got 4 colored bands printed on the resistor. And each of this color corresponds to a particular number. So the first color will tell you the first digit of the resistance. The second color tells you the second digit of the resistance. The third color gives you what we call a multiplier. And the fourth color gives us a tolerance. So what this means is that, let's use this as an example. Okay, this is a yellow color band. So therefore, if I look at the color code, yellow corresponds to a number 4. That's why the first digit is a number 4. The second band is a purple colored band. So I look down over here, purple color, and therefore the second digit is a number 7 because it corresponds to purple 7. And if I look at the third band, it's an orange band, corresponds to 1K. 1K is 1000. So therefore, it's 47, the first 2 digit, multiplied by 1000, which gives me 47,000 ohms. Okay, or you can just write 47 kilo ohms. And then I have a last band. Okay, a last band, this is a gold color band. So therefore, I look at gold, which is 5%, plus minus 5%. So let me explain to you a little bit about this tolerance. Now, when the manufacturers manufacture resistors like what you see on the screen, the carbon resistors, uh, they can't manufacture a precise resistance. Just like anything that is part of the manufacturing process. Even a table, when you have a table being cut into, let's say, 1 meter by 0.5 meter length and breadth, not all will be exactly 1 meter by 0.5 meter. Okay, there's usually going to be some sort of tolerance, simply because maybe by the first cut by the saw is going to be a perfect 1 meter by 0.5, but after sawing 50 pieces of wood, it's going to be slightly blunter, the blades will be slightly thicker, and then instead of maybe 1 meter, there's going to be a 1 mm or 0.5 mm difference between the first cut and the 50th cut. Okay, so in the manufacturing process, not everything is going to be super, super precise. So carbon resistors, when they promise you plus minus 5%, tolerance. That means you get maybe not exactly 47 kilo ohm resistor, 47 kilo ohm, but maybe just slightly, possibly 5% more or 5% less. So within that plus minus 5% range, you will be assured of this resistance. Okay, but you will not get exactly 47,000 ohms. Okay, so this is what it means. So like this little chart explains the tolerance. So instead of 100 ohms, you have plus 5%. This is the gold band. You have 105 or minus 5%. This is 95. So you are assured if you buy a 100 ohm resistance with a gold band that the value you will be getting will be between 95 and 105. Okay, you're not going to get a precise 100 ohms. If you do, good for you. Okay, so this is a worked example. So they show you brown, green, red, gold. So the first band, brown, will correspond to a first digit 1. Green corresponds to a digit 5. So you have 15. And the third band, red, corresponds to a multiplier of 100. So 15 times 100, you have 1500 or 1500 kilo ohms. For band gold, so you have a plus minus 5% over here. Okay. In case you are worried that you have to remember this table, the color codes, you don't have to. This color code table will be provided for you in the data sheet at the start of every electronics exam. Okay, so you do not have to remember this color code table. This is another example. You can do it yourself. Don't look at the answer. Try it out. See whether you can get the answer. Next part, E24 series. So, um, the manufacturer doesn't, of course, manufacture every single value of a resistor. It doesn't manufacture 100 ohm resistor, 101 ohm resistor, 102 ohm resistor. No, it's impossible to manufacture so many different kinds of resistors. So what they do is that they have fixed resistor values that they manufacture. And what we are going to do is we are just going to look at this E24 series. Okay, it's a slightly more differentiated series with 5% tolerance, the gold color band. And what happens is that these values are the base multipliers that they manufacture the resistors in. So what this means is that this value 1.0 means that they manufacture maybe 10 ohms, 100 ohms, 1000 ohms, 10,000 ohms. Okay? So long as there's a 1 and you can multiply by 10, 100,000, 10,000, 100,000, whatever it is. Okay, so this is what they manufacture in. So they don't have a 1.4. If you see here, they don't have a 1.4. So you can't buy a 140 ohms. You can't buy a 1,400 ohms. You can't buy a 14,000 ohms. What you can buy is if you look here, 1.3. You can buy a 130 ohms. You can buy a 1300 ohms. You can buy a 13,000 ohms, and so on and so forth. Okay, so you do not have to remember this E24 series table also. It will be provided for you, but it's also good to kind of know some common resistor values from the E24 series. Okay, so this explains the E24 series from 1.0 all the way to 9.1. Okay. So usually for any calculation or application, we would calculate the problem and come up with a value of resistor that we need. And using that value, let's say I do certain calculations and I find that, oh, I need a 7K ohm resistor, 7,000 ohm resistor. I'll come to the E24 series and I'll see 7, 7, 7, 7, 7, 7, and I only have a 7.5, okay, or I have a 6.8. So I can't go to a shop and say, I want to buy 50 pieces of 7K ohm resistor simply because they don't sell it. And they don't sell it because they don't manufacture it. They only manufacture 6,800 or 7,500. They don't manufacture or sell 7,000 exactly ohms. Okay? Can? But usually what we do is that we usually either choose the closest to the calculated value, but if your application is to limit the current, that means you don't want too much current to flow through, then instead of choosing the closest value, what we do if we want to limit the current, don't want our appliance to burn out through a high current, what we usually do is that we choose the next higher from the calculated value. Okay, so it depends on the situation. Do I go the one below or do I go to the one above? So if I calculated one that needs a 7K ohms, depending on what application this is for, I can choose the closest one. Or if I want to limit the current flowing into the circuit, I choose the next higher one, which is 7.5, depending on the situation. All right. So this is a worked example. I've got a 25 ohm bulb. Always have a resistor in series with your appliance. It's always a good habit. So the question states that I cannot have more than 30 milliamps. Okay, I cannot have more than 30 milliamps, otherwise the bulb will blow. So already in this situation, you are talking about limiting the current, limiting the amount of current flowing. So remember this. Okay, so I'm going to use V equals to IR, Ohm's law, calculate, and I realize that the resistor that I need over here, the total resistance is 300 ohms. So if I'm going to take away the 25, already I know 25, I now know that this resistor I put in series is 275. Now, let's go back to our E24 series. Remember, 275. So going back, I look at 275. I don't have a 275. Okay, I don't have a 275. Now, but remember, I want to limit the resistor. I want to limit the current. Although the closest is 2.7, which they sell a 270, right? But I don't choose this. I don't choose the closest because I want to limit the current. Therefore, if I want to limit the current, I need a higher resistance instead of a closer, lower one. So I would instead choose 300 ohms. Yes, the current will be slightly lower, but it's okay because I want to limit the current. Okay, I may not be able by using this value to get the brightest output of the lamp, but at least I protect the lamp from blowing. So that's what I mean by choosing a current limiting resistor. Okay. So if we look at variable resistors, same like fixed resistors, they don't have a manufacturing facility where it manufactures every single resistor value under the sun. So they manufacture standard values of variable resistor. You just need to know a few standard 100, 200, 500, 1K, 2K, 50K, things like this. Okay, so variable resistors, that means if I look at this value, 20K, it means that this variable resistor is able to give me resistance from 0 all the way to 20,000 ohms. That's what it means. Okay. Now, besides looking at the color bands of the resistor, there is another way that we can use instrument to measure the resistance of a resistor. And this instrument is called a digital multimeter. There is a symbol over here. Let me try and zoom it in for you. So you just need to turn the knob to the ohm symbol. And once this is turned to this ohm symbol, whatever you put in between the two probes will measure the resistance of that component, like so. Okay, as shown in this picture here. Put the two probes on two ends of the resistor, and it immediately it'll tell you the resistance of that resistor. So that's another way. Okay, so do this review question. Try to do it yourself. And then if you have any questions on this, you can come back and ask me. Okay, so maybe I'll do the first one for you. I'll do the first one for you in case you're not sure. So they want to write down the color of these first, second, third, fourth band corresponding to 330 ohm. So straight away, 5% I know because I remember it. It is gold. Okay, the tolerance 5% is gold. So now I look for 330. Okay, so I go back to my color code table. Remember 330. Okay, so I'm looking at 3 orange, 3 orange, O times 10. Okay, so it's 33 times 10 to give me 330. Okay, 33 times 10 will give me 330 ohms. Okay, so I go back to my review question here. So I know it is orange, orange. Oh crap, I forgot what the times 10 is, what color it is. Let me do a quick scoot up. Brown. Okay, brown. And then I write down brown. Okay, so try this, try the rest. If you got questions, you can ask me during class. Last question, remember, limit the current is to limit the current. So don't choose the closest, smaller one. Instead, choose the next higher one. Remember this. Okay, so try out these review questions. If you got problems, you can look for me during class. And if there's any other thing that you need to re-watch this video, please stop now, re-watch it before going on to the next video, which is part 3.4. Okay.